Let's see how to use embedded HANA machine learning via a Python client. Here you see I am in a Jupyter Lab environment. First of all, the main prerequisite that we need is to have the HANA ML package installed. And you can install it using the pip install command exactly in the same way as you would do with another common Python library such as pandas, etc. Secondly, HANA ML, as the name says, runs embeddedly in HANA. So we need to have an HANA database and we need to create a connection between our client and the HANA database. In our case, we have said that we will use the HANA layer within our data warehouse cloud tenant for this demo. Also, in this demo, I'm using a Jupyter Lab environment within Data Intelligence. This is not mandatory. I could have my notebook locally on my laptop, but the advantage here is that in Data Intelligence, I have already configured my connection to the Data Warehouse Cloud. So here I can just open the connection by calling it by its Data Intelligence ID with this line of code. So you see that if I open for a second my connection management, you see that I have a connection that is called with the same ID, DWC part. If I had the connection, if I had the notebook in my laptop, I could still connect to the notebook. The syntax to connect will be just a little bit more involved, and I will need to provide here the DWC host, port, username and password, etc. So once we are connected, we can load one of the DWC table to a HANA data frame with this line of code. So you see the dev is the name of the schema, CV sales data is the name of our DWC table. And we can also show how it looks like. So let's display the first 20 lines, for instance. So in this case, we are looking at a table containing sales order for a children bookshop. So one thing that it's important to understand when we use HANA ML is that the HANA data frame is an object that lives in memory in the HANA database. It consumes resources of the HANA database, and all the operation that we execute on this object with HANA ML will use the computing resources of the HANA database. Now, when we execute the collect statement on a HANA data frame, we are extracting the data from HANA and we are storing them in a pandas data frame. That is one of the most basic objects in Python to deal with tabular data. On this object, you can execute all the Python operation that you want. You can use pandas, you can use scikit-learn if that means something to you, etc. In this case, the Python data frame lives in the client and uses the memory of the client. The operations that we execute on it use the CPU on the client side. So this is a difference that becomes relevant when you need to execute complex operation on huge dataset. In this case, we will work only with HANA ML, so we will not need to export any data from DWC. We want to use our children books historical sales data to develop a book recommendation engine. We will need just 3 columns for the analysis: order ID, book ID, and book title. So let's use the select statement to keep just 3 fields from our HANA data frame. We will use one of the algorithms available in HANA-ML to crunch the sales order data and do what is called a market basket analysis. That is to say, finding pairs of books that are often purchased together. The algorithm that we use is called a priori. It is a simple one for association analysis and it is part of the PAL libraries. When we call fit, the algorithm starts to run to find association. And let's see the results. So the result come in the form of an in-memory HANA data frame as well. If we display it, we see that the algorithm found 1,720 books association, and you see them here in the form of antecedent consequent pairs. So customers that bought the antecedent have also often bought the corresponding consequent book. for instance, customers that bought the Willoughby Fair mystery also bought the Rat of Atat mystery in association with it. And this doesn't surprise us, as they are both issues from the same book series by Enid Blyton. Another example, you can see it here. For instance, I wish that I had duck feet goes together with click clack moo. So the algorithm seems to work well. We are satisfied with the result. So say we want to keep this table as a reference and implement the recommendation in the bookshop online website based on this association table. So we need to persist it. Remember, right now, this table exists just in memory in HANA, and it will be gone forever as soon as I close the connection between my client and the database. So to save the table, we can just use the save command with the table name that we want. And as you can see here, if I go and see my DWC schema, we see that this new table was created.